As we move through this coronavirus crisis, we have to look at testing. We've got to deal a lot with testing, and the issue right now is that we're just assuming that the tests are 100% accurate. So what I'm doing is I'm looking at the data from Pennsylvania, because as we get closer to the United States rather than globally, it's easier for us to get the data we need. So I went to the Pennsylvania government website, and this is from yesterday, April 4th at noon, because we don't have the April 5th data yet. There were 60,013 negative tests, 10,017 positives, and 136 deaths. So those are the most accurate data we have at this point. So I took those data and made this table based on sensitivity and specificity of a test. So if you're not familiar with these terms, sensitivity, I should have a Y here, excuse me. Sensitivity is the probability of testing positive given one is disease positive. So you think that everybody who has the disease will test positive, but that's not true. The tests have to be valid, and this is a characteristic of a test. So is specificity. That's the probability of testing negative if one is disease negative. These are the best data that I could find to date. Not everybody's publishing these, and I don't know why. Maybe they just haven't done the studies, or I have no idea yet. But this one I found, it's from a journal article called Developing and Clinical Applications of this antibody test for SARS-CoV-2 infection diagnosis, Journal of Medical Virology. This is the author. Here's all the information you need. So we're looking at these tests, right? So what we have here then would be the assumption that it's assumed that these tests are 100% accurate by most people. So if this was the case, of the 70,030 individuals tested, those 10,017 who have tested positive represent the prevalence in Pennsylvania, right? But that would be a really, really high prevalence, because this is 0.14. This isn't even multiplied by 100,000. So it's probably that people who are being tested are sick, so the prevalence will be higher among those individuals than others. Let's just assume that this is the case right now. And if we calculate the number of true positives based on that number that we have, 0.8866, right, we would have 8,881 positives who are true positives. We'd have these false negatives, people coming back as negative when they actually have the disease. It's 1,136. This is just the difference between 10,017 and 8881.072, right? So, and then using the specificity value, I'd multiply 0.9063 times 60,013, and I'd get 54,389, meaning that these here are false positives. It'd be 5,623 false positives. So then all these would add up. Our total individuals who actually tested positive were either negative, false positive, or true positive would be 14,504.29, and these would be the negatives who tested negative, and we get back to the 70,030. So that's what we were assuming is going on here. So we're just using these data as prevalence, at least among tested individuals. Now, if we were to use the U.S. prevalence, which is in reality a lot smaller, it's, what did I have it here? Prevalence, well, it's pretty big compared to other countries. Right now we're 79.3626 per 100,000 individuals. So I use that value to calculate what would be the expected number of individuals who would have the disease based on these 70,030. So again, it might be different, because this would be assuming that these 70,030 are randomly chosen from the state of Pennsylvania, which they're not. They're people who probably are afraid or felt some symptoms, right? So in that case, we would have, using that U.S. prevalence, we'd have only 56 individuals who are sick out of this 70,030 who tested. If we multiply that by the sensitivity, we'd have 49 individuals being true positives and 6 being false negatives. Then with this specificity, we'd have 6,557 Yes, 6,557 false positives. So that would give us a total of 6,606 positives, testing positive, and 63,000 testing negative. We get back to the 70,030 value. Well, let's use these data and calculate what would, just ignoring the testing that was done here in Pennsylvania, but just using the Pennsylvania population, the US prevalence data, the sensitivity and specificity, and see what we get. So there, as of 2020, there's an estimated 12,820,878 residents in Pennsylvania. And if we use this population prevalence for the US, we'd have 10,175 people who are disease positive, and these 12,810,703 are disease negative. Out of those, we'd have 9,021 true positives. We'd have 1,153 false negatives. We'd have about a lot of 11 million something true negatives, and then we'd have 1,200,000 false positives. So, what does all this stuff mean? It means that testing isn't necessarily accurate, and you can't trust these values and take these values as truths. You shouldn't take these values as truths. So when I go to that website and I see there were 10,017 positives, I'm saying, okay, well, are these? They're just tested positive. They could be true positives or false positives. So I just got to keep that in mind. So this may mean that the situation isn't as bleak as we make it seem. We cannot just trust what we see. We have to we have to make appropriate inferences based on all of the data. And you need to be able to make these kind of calculations to understand stuff. By the way, I have my students do this stuff all the time. Now, if somebody has better sources for sensitivity and specificity, please send them to me. I'd love to have them and redo these calculations. But thank you very much. Have a good day and be safe, please.